Welcome to this episode of arcade-cabinets.com, PCB repair, step-by-step diagnostics of Atari Xevious. In this episode, we finish where we left off in last episode. We use the Fluke 910A, multimeter, oscilloscope, and some physical viewing of the board behind a lighted background to find the final issues and fix this game. Thanks for joining us. Hope you enjoy it.
So, welcome back. Today we're shooting for the first time ever in 4K definition. So I got a new 4K camcorder, and this is an actual real camcorder rather than the little cheap Chinese GoPros that I've been using. So I want to thank all the people who support me on Patreon. Your support makes this type of thing possible. I forgot to mention that this guy right here. I never bothered to test this RAM, and obviously I should do that before I even bother testing. I tested the RAMs on the other side of the board, but there's a RAM here. We'll see if in the schematics on the memory map at address 7800 to 7BFF, and I completely forgot to test that. So let's do that. We'll do a RAM long 7800 to 7BFF. Oh, power fail. Helps if I turn it on. So RAM long 7800 7BFF, and instantly we get a BTS bit 1 issue on every address. So it looks like bits 1 is bad. Now, normally I just pop another RAM in, so let's do that. Because that's easy, it's socketed. So pop another RAM in and try again. Still have the same problem. Now, because these Xevious boards are so crappy, normally I don't replace the sockets. I would actually do some diagnostic work first to verify what the problem is. But I'm going to just go ahead and replace the socket because these sockets are horrible. So when I get back, we'll have a brand new socket and see what happens. So I replaced the chip. Let's try it again. Or replace the socket and the chip. But we still have a BTS error on 1. Okay, fair enough. Often replacing the sockets I usually don't bother because it's usually not the issue. But in this case, I worked on the last 6 Xevious boards in the last week or two, and all the sockets have been just horrible. So even as I was removing this one, like 4 pins fell off. So in this case, it wasn't the issue. So let's do some more traditional troubleshooting. What I'm now going to do is I'm going to pull up the schematics actually and see how the RAM connects. I can't imagine there's anything in the way of the RAM, honestly, on the Z between the RAM and the CPU, but we're gonna find out. Oh, here it is. 1H. So 1H has a buffer between it and the data bus. LS245 at 5H. So what we can do here is we can find out what pin BTS1 is. I always forget whether that's the 0th pin or the 1st pin. But what I'm going to do is find that out. First of all, I'm going to look in the Fluke schematic or manual, and then we're going to test. We're going to write and read data and test that chip to see if it's actually sending and receiving the data correctly. So let's go ahead and test this chip. Now, first thing I do is I'm going to put my probe on the chip select because I want to only sample the data when this chip select goes low. And that's pin 18. 14. Right there. Okay. Now, the bit the low bit on the RAM is actually pin, looks like 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And you can see that as low. Okay? Whereas 10 is high, 11 is high. So the question remains at this point is, was the data ever getting set to the chip? Or was something blocking it, like this buffer, blocking that data from ever getting back? Because it's coming back wrong from the chip. But I replaced that chip, so I think actually what's probably happening is that buffer chip is never sending the correct data. Because if it was, then it should have worked when the other chip was in. Because the only thing between this really is this buffer, between the CPU, is this chip and this. And the custom chip. Okay. We could test that. We could test that by trying to write it high, which we'll do. I'm going to go ahead and do a write to 7800 and put FF in and make it loop. And now let's test the write enable, because we only care when this goes low. And that's 21. So 13, 14, 15, 16, 17, 18, 19, 20, 21. So when that goes low, let's test what chip 9 looks like, or pit 9 looks like. 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's low. Let's look at address data bus 1, which is at 10. That goes high. And 11. So it looks like the data is never making it to the chip. So I'm betting that buffer chip is bad. Okay? Betting that buffer chip is bad. So let's go ahead and remove that buffer chip. So we replaced that buffer chip and we're still getting a RAM error. So now we have to figure out what could be going wrong. I can't imagine I have to imagine that we have a bad trace between 5H and wherever feeds it, which is the custom at 4L. Because had anything else, there's a lot of things on the data bus that could screw it up. And that's one of the problems when testing buffers and buses in general, is lots of things can screw it up. But since it could read from the video board RAM, that has to go across the bus. So I'm thinking there's something has to be between this guy and there. So let's look for continuity. So it looks like pin 11 on 5H goes straight to pin pin 12 on 5H goes straight to, that's a low bit, pin 10 on the custom at 4L. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 4L. And we do have continuity. Well, look at that. Something, I don't know. That's interesting. What could be screwing that up? What could be screwing that up? Let me just make sure that I put this chip in correctly. What I'm going to go ahead and do is I'm going to actually test this now with a chip not even inserted. I want to see what's going on with nothing going on the bus. Pin 12 is high. High. Okay, so nothing. There's no other signal on the bus. Put a new chip in. Well, you know what? Let's check continuity between this side of the buffer and this chip, because that could be it. And again, we're looking at the low bit, which is pin 9. Here, And on this side of the buffer, it's pin 8. 1, 2, 3, 4, 5, 6, 7, 8. And we have continuity there. Well, I'll be darned. That is interesting. I do not know. Let's do a write of FF looping to this and test this again. I want to see what comes in on that side of the buffer now. So we got pin 21, which is 24, 23, 22, 21. Let's see what's coming in to pin 9, which should be high, but it's low. Let's go to this side of the buffer, which is pin 8. It's low. Let's see the entry side of the buffer, which is pin 12. 12. It is high. So it's coming in high. And it's going out low. And I just replaced that chip. So 12, let's try that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's coming in high, as you can see. But when it goes out at 8, it's going out low. So maybe is it possible that this pin is somehow grounded between pin 8, 5H, 8 and pin 9 here. We do have continuity. I'm going to do just... Oh. That's interesting. Look at that. I also have continuity with ground. So there's a problem. Somehow, somewhere along this path from here to here, pin data bus 0 is bridging ground. So we have to actually find out how that's happening. That is going to be easier said than done, but I'm just going to trace the path and see what I find. And I think I found it. Let's head it up there. Wrong area. Do you see that right there? I believe that's our problem. Because this little dot here is what gets the signal, and this looks like it's traced to ground. We're going to go ahead and just use our X-Acto knife to just clear that out. And now let's see if we have continuity issues still. 1, 2, 3, 4, 5, 6, 7, 8, 9. We do not. So I'm hopeful once we put this back in, everything will work. Okay, firing it up. RAM long 7800 to 7DFF, and it's not immediately coming back with an error, so that's positive. And while it's running, I want to point out, remember how I showed you I held the PCB board up to the light like this? That really helps me out a lot. I can usually find traces, smashes and traces and cuts very easily. Well, not very easily, but a lot easier by doing that. So I have a nice high power LED. No, is that LED? I think it's a LED light. It's like one of those fluorescent looking LED lights, but it's LED. And that really works out very well for me when I do that. I also will like to hold it at an angle sometimes because you have to get this right, but if you hold it at the angle, you can see the metal like actually pops up and shines, and it will actually help you if you don't see it through. Usually just putting it straight up perpendicular helps me, but sometimes I hold it at angles, and that will often help. And sometimes you can actually see underneath when there's underneath sockets if there's a messed up trace by doing it at the angle. So we're still waiting for this to come back. I'm pretty sure it's gonna be successful when it does. Came back, everything's okay. What I'm gonna do is go hit run UUT at 0, which should kick it and cause it to do this. And there we go, it's booting up. So once we put the rest of the chips in, it should hopefully work. Oh, it's putting a lot of credits in, so I must have the credit multiplier up high. Okay, so it looks like it's working.
So there you go. We have a completed Xevious fix, and hopefully you learned a lot about how the system works and how to isolate the different components and test them one at a time. As always, please hit that like button, tell your friends or people that you know who might be interested in this type of material about it, and consider supporting us on patreon.com.